what is the use of the water supply? So the only use of that water supply, the water supply coming to the house, if that water supply is a copper pipe, it is metal being a good conductor of electricity. It is how we can make the dangerous power go into the ground and make it safe for us. So the purpose of that pipe is only so we can connect the ground to let the ground wire go into the ground as deep as possible. For example, if we have a different type of pipe, a plastic pipe that brings the water into the house, we're not going to bring the ground wire to that pipe because it's not metal. Then we would need to use a grounding rod or a grounding plate. Let me give you a good example of a grounding plate. So over here, if you look at this first image, this is the top of a grounding rod. So here's the ground wire. This is a lug. We secure the wire to this rod. That rod will be 1 inch in diameter, 8 feet long, and we drive that into the ground. This is a grounding plate. So we would connect the wire to this plate, and this plate, we would make sure it's deep in the ground, at least 6 to 8 feet in the ground. And we would use a grounding rod or a grounding plate if the water supply is not copper. So that copper pipe is deep in the ground. It's going to be at least 6 feet in the ground. And because it's copper, it allows the copper wire to continue making that power flow through the copper pipe. So continues the wire into the ground. Clarification there? Does that make more sense? Excellent. We're going to go back to our images here. Let's take another great example of our service panel. We're going to show you how we're now going to utilize 240 volts. For example, remind us once again, ladies and gentlemen, I'm going to change this question up just a little bit. Can somebody tell me if I'm going to connect a clothes dryer, your electric clothes dryer, what amperage do I need to use and what size wire do I need? American wire gauge number 10. So for our clothes dryer, we need 30 amps, American wire gauge number 10, and the voltage of that dryer. What is the voltage of that dryer?
240.
240. So that means we have to send to the dryer 120 volts 2 times. 120 and 120 makes 240. Let's do that right now. So we are going to connect a dryer right now, ladies and gentlemen, which means I need to connect. Let's put the dryer on this side. I'm going to put a wire here. Okay, and the wire I'm going to use for a dryer is going to be American wire gauge number 10, 3 conductors. Okay, so if we now are going to connect this, we are going to put a breaker that sits. If you could see the hot bus bars in the middle, they stagger each other. You see how they're staggering each other? This allows me now to put breakers on this side and this side. And if I need to use both bus bars, I can. So now this breaker is going to sit on this bus bar and this bus bar simultaneously. You see that? That is right there. I now need for this 30 amp breaker. 30 amps. 30 amps. Let's connect the wires, ladies and gentlemen. Simply, we are going to start with the first wire, which is the easiest. We come in, ground wire. I'm going to connect it to the ground bus bar. Neutral. I'm going to connect it to the, there's my ground. Here is the neutral. I'm going to connect it to the neutral bus bar. That leaves us with 120 volts with the black wire. I'm going to bring it in. I'm going to connect it to the one side of my breaker. 120 volts with the red wire. And I'm going to connect it there. So now I've got 120 volts, 120 volts. They are now going to my dryer. 120, 120, that's 240. And the neutral brings the signal back, and the ground. Fair enough, ladies and gentlemen. Did you see how we made that connection? I'd like to do a little bit of a review. Jamal, you have a question for us? Okay, if we can explain the panel in brief once again. Why don't we get a real panel as well? I'm going to put this one in the background so we can compare the two, and we can go back and forth. This is a Siemens panel, very good brand. And of course, see, when we have covers on your electrical panel, you see there's covers on it. Usually the cover is in two separate pieces. Unfortunately, this panel right now, the top portion of it is covered. So I'm going to help us understand what's going at the top. As you can see down below, we have all of this exposed. Okay, to help us understand a little bit better, I want to zoom in a little bit more, and we're going to explain what's going on at the top here. So we move in a bit here. This cover, once you've made your main connections, to work safer, we like to cover this once again because we don't need to have wires that are exposed with more power. But if we were to remove this cover over here, in behind, we would have the conduit, which is bringing the wires in. Let's show us the conduit, ladies and gentlemen. Imagine, if you will, we have inside here, behind this panel, the conduit where the wires are going to come out. So let's see what's going on in behind. Of course, what I first want to point out also, if we take a look over here, I'm just going to highlight it in this purple color. This right here is our main circuit breaker. That's the main circuit breaker there, ladies and gentlemen. So that circuit breaker there, before we zoom in a bit more, we're going to just show you what's going on. Let's bring those three wires into the house. First and foremost, if we can, I might want to just scroll up a bit. We're going to move. We're going to lose some of this stuff. Let me scroll up just a teeny weeny bit. There we go. I'm going to just scroll up to there. Now we can see a whole bunch of, see all these breakers on this one side? Well, they're hiding, if I can scroll down, this bus bar. So here's one bus bar. There's the other bus bar. Are we seeing that there, ladies and gentlemen? And when we look at these bus bars, you'll see this bus bar over here. Intertwining, that bus bar has got a blade that sits in the center. And it sits, half of it sits on this side, and the other half sits on this side. You see that? And they alternate. The next one from this bus bar is here. The next one from this bus bar is here. The next one from this bus bar is here. Okay? And then the next one is here. So no, they're not connected to each other. They just, if you could see, that's that bar. Let me show you the other bar. This bar over here, as you can see, it's over here in behind these breakers as well. But now you see this blade coming out here. This blade coming out here. They're not touching each other. They're not touching each other. You see, they're intertwining with each other. Every other one. In behind this breaker, there's a blade here. In behind this breaker, there's you can see the tip of it sticking out right there. You see it? Now, they interlock each other. Okay, so they sit, each bus bar comes into the middle. And now it allows me, if I can sort of simulate right here, you see this bus bar that I just put there? When I go to place, let me grab a different color. Imagine this is a breaker. I can put a breaker on this side, and it's touching only It's on this bus bar. You see? It's on this bus bar here. So this breaker on this side is making contact to this bus bar right there. You see that? Now, if I put a breaker on this side, let me grab another color. On this side, I put a breaker on this side, but it's making contact to this bus bar. Okay, so when I go to if I go put a breaker just below that one over here, this breaker is making contact to this bus bar. But it goes into the middle, so if I need to put a breaker here, there's a breaker here, but now both of these yellow breakers are making contact with this bus bar. Both of these breakers right above are making contact with this bus bar. Does everybody see how that works now?
Yeah.
Are we getting a better visual as to what's going on? So I am, if you want to study this a little bit more, I might make this just a little bit smaller. I might even see if we find another panel that's a little bit more bare. But let's just scroll up once again just to see what's going on. Now, if you take a look at this main breaker over here, what we can't see is we've got this bus bar here, and we've got this bus bar here. But once we get over here, we've got the blade of one bus bar here and the blade of the other bus bar there. So now what's going to happen, ladies and gentlemen, when we connect our wires, let's bring the wires in. Here is my conduit. Here is the main conduit coming into the house. I'm just going to put it here simply. Now, let's bring the wires in, ladies and gentlemen. We have here, ladies and gents, I'm going to grab my marker, the neutral wire. Of course, first and foremost, here is, maybe I might need to point this out once again before we continue. So we looked at our hot bus bars. This is my neutral bus bar over here, ladies and gentlemen. That's a neutral bus bar. And it will go all the way around. And that's also the neutral bus bar. And then over here, this is a ground bus bar. This is also a ground bus bar. You can see how the ground bus bars are making direct contact to the metal box. Fair enough? So now, let's bring those wires in. Here we go. Here's my conduit coming in. Let's get just this color here. So here's the conduit. Here's our conduit. And inside the conduit, coming from the hydrometer now, ladies and gentlemen, here is the neutral wire. Here's the neutral wire. Oops. Here's the neutral wire. It's going to come in. I can either connect it to this neutral bus bar, or I can bring it to this neutral bus bar. Because the wire is coming in all the way over here, I'm going to work as cleanly as possible. So I ran the neutral to the neutral bus bar over here. Fair enough?
Yeah.
Now let's get the black wire, ladies and gentlemen. We're going to get the black wire, which is 120 volts. The black wire is going to come along, and I'm going to connect it to either here or here. It doesn't matter. It's just bringing in 120 volts. Okay, when I bring this in here, I brought 120 volts to the top part of this 100. If you can see, this is a 100 amp service. You can see the number there. Does everybody see that?
Yeah.
So this is a 100 amp service. Now we need to bring the red wire 120 volts in. Here comes the red wire, and I'm going to connect it over here. So now I brought 120 volts here and 120 volts here.
Up to 14.
Okay. This black wire may be bringing the power to this bus bar, and this red wire may be bringing power to that bus bar. Either way, they're both bringing 120 volts to one bus bar, two bus bar. Fair enough?
Okay.
So when I make contact with one single breaker on either side, this side or this side, I'm only getting 120 volts. If I make contact to both bus bars, I'm going to get 240 volts. Okay, one more thing I want to show you before we continue, because I'm going to be scrolling up in a second, is if we take a close look, also in behind here, here is the ground wire that is going to be going to the ground plate or ground rod or water supply. Okay, it's going to be connected underneath in here, in this particular case, to the metal housing of the case. Once we touch the metal housing of the case, now this ground is connected to this ground and this ground over here. Now it's all interconnected because it's going directly to the metal. Fair enough? So that is where the ground is connected. Now, let's remove this. We're gonna lose all these wirings. So if you need to take a little picture of what we've got here, that might help, okay? And actually, if you want, I can even identify these for us. Let's do that quickly, ladies and gentlemen. We're gonna come here and we're gonna say that this here is 120 volts. Okay, a little bit hard to see. I'm just going to move that up here. And let's get a 120 volts. That's also 120 volts. All right. And then this over here, ladies and gentlemen, that is my neutral. And then here, ladies and gents, we have our ground.
Yeah.
And now you can see where everything is getting connected as well. So if you need to take a picture of that just the way it is, by all means, take a picture of it. We're going to scroll down and we'll use some of the wires that are in this box already to help us visualize some other connections. Those three wires that are coming in over here are either coming in through an underground feed or an overhead feed. They go to the meter, and then from the meter, they come into the house. Here, while we got the opportunity, if you take a look at the box, the panel box, you can see all these little round circles there. We call those knockouts. That's where we would place, and once we knock that out, we can connect the wire onto the box so the wire doesn't run away from the box. Okay, let's remove this stuff here now because it's going to be in our way. Again, every manufacturer might be different. In some cases, you could bring the ground wire directly to one of these ground bus bars. See, for example, here is, in this particular case, why the heck isn't that? Okay. In this particular case, we've got a ground bus bar here. We got a ground bus bar here. In some panels, you might even have a ground bus bar along the bottom. It's going to be connected to the box. Okay, now from this other end, so that's connected to the box, and now that's going to be grounded. It's going into the ground. Fair enough? Let's zoom in to some of these breakers here. You can see on some of these breakers, we can actually read the amperage. For example, here, let's take a look at this one here. There we go. This is a 40 amp circuit breaker right there. What would I need to use that 40 amp circuit breaker for? The stove. What wire gauge does a 40 amp circuit breaker require? American wire gauge number 8. When we look at our 40 amp circuit breaker, ladies and gents, the wattage for my stove is going to be 40 amps times 240 volts. Okay, 240 volts. That gives me a total of 9,600 watts or 9,600 watts. then the safety capacity of that, ladies and gentlemen, is going to be 80%. If we take a look, here is my stove cable right here. I'm going to highlight it in an orange color. This is a stove cable right here. You see it? And if we take a look at the wires, how they come into the box, you can follow the ground wire. The ground wire is going to the ground bus bar. Let's follow the neutral now. The neutral. Here's the neutral. It comes out. It's going to the neutral bus bar. Now we've got our black and red wire. The black wire, you can see it. It's coming out over here. Follow it, follow it, follow it. It's going to one of the screws on my 40 amp circuit breaker. And then if we look at the red wire, here's the red wire. It's coming out. And it's going to the other screw. So now this red wire is bringing 120 volts to the stove, and the black wire is bringing 120 volts to the stove. Fair enough? Then it is coming back with the neutral. Follow the neutral. You see we got this bar that goes from one side to the other side to connect the neutrals together. All my neutral wires go to the neutral bus bar. All my ground wires go to the ground bus bar. All the hot wires are going to a circuit breaker. Fair enough? I would like to show you how we would make the connections to the same stove receptacle. So the stove socket, the stove receptacle. So imagine, if you will, this is the connection inside the panel. Let's go to where we would be plugging the stove in. So when you're plugging in a stove, or for that matter, even a dryer, when we look at a stove receptacle or a dryer receptacle, they're going to look exactly the same. Let me see if we can take a look at the back here, just as far as our connections are concerned. This might actually be pretty good to look at. So again, this is the back side of the stove or dryer receptacle. They look exactly the same. The only difference is the stove receptacle is designed to handle 40 amps. The dryer receptacle is designed to handle 30 amps, but the connections are going to be exactly the same. So if I can just show us the front side of this, if we look at the front side of a stove receptacle, it is going to look like this, for example. This is my ground. This is my neutral. That is hot, and that is hot. So this is what it looks like from the front. Let's go back to the back. I want to show you the back of this, the connections. So when we look at the back side, ladies and gentlemen, a little bit hard to see. I'm going to zoom in. Of course, you can see over here what we've connected is the ground wire, the bare ground. Usually, if you take a look on top here, it will have the letter G or, yeah, it'll have the letter G for ground. Okay?
Okay.
Ground wire. And if you look at the other side of it, you're going to see that big hole. There's my ground. Again, you can't see it, but most manufacturers on top over here, you're going to see the letter B/R. On this side here, you're going to see the letter B/R. B for black, R for red. B for black, R for red. It doesn't matter, ladies and gentlemen. If you could see, this person connected the red wire on this side and the black wire on this side. He could have easily put the black wire on that side and the red wire on that side. It wouldn't have made a difference, because all we're doing is we're providing 120 volts here and 120 volts here. Combined, That is my 240 volts. And then at the bottom, you can see the white wire being connected, and it will say over there, W for white or N for neutral. Fair enough? So
Yes.
that's what we need to make sure. We connect the neutral where it belongs and the ground where it belongs. But as far as our hot wires are concerned, it doesn't matter if you put the red wire here or the red wire there. Doesn't matter if we put the black wire here or the black wire there. A little tip, ladies and gentlemen, myself, when I'm using more than one color, I always like to put my red wire on the right-hand side. Just so in my mind, I know how I want the power to flow. But that being said, it doesn't matter. That's how we make the connections to the stove plug. Then when we plug the stove in, you're going to have that big plug, and basically not the whole stove requires 240 volts. Part of it only needs 120 volts. The other parts needs 120 volts. So that gets distributed throughout the stove itself. If you look at a lot of stoves, the newer ones, you're going to have a lot of computer chips in it. But if you look at an older stove, if you open the top, you're going to see a bunch of smaller fuses there, which are going to go to various parts of the stove to control it. Fair enough?
No.
All right then. So hopefully that was able to clear up how we would connect our stove. A little bit of a recap just to make sure we didn't forget a lot of things that we talked about yesterday. I'm just going to throw out some random questions. For example, rule number 1, ladies and gentlemen, when we are working with electricity, whenever you're going to do any kind of repairs, or you know there is existing power, whenever possible, always turn the power off. Okay? Always turn the power off. Don't be like me. Many times I've worked with the power on because sometimes you have no choice. You have to work with the power on. But do not work with the power on unless you really know what you're doing. For example, if we are replacing some receptacles or we want to change a light fixture and we don't know where the power source is, we can turn the circuit breaker off to what we're working on. Simply put, if I'm just changing a light fixture, we could just make sure that the power is off of the light itself. But if you want to work even safer, always turn the circuit breaker off. Can somebody give me maybe 2 or 3 safety approval markings? CSA,
Yes.
Canadian Standards Association. Very good.
ULI,
UL, Ontario Hydro. Those are good safety approval markings. When we were talking about wires, if it's one wire by itself, it's one conductor. Okay, if we have more than one wire in a cable, we have more than one conductor. So when we are going to connect a stove, we need to have 240 volts. And we also have to have a neutral. So for a stove, we need American wire gauge number 8, 3 conductors.
Okay.
1 neutral, 1 black hot, and 1 red hot. 120 volts, 120 volts, neutral, and the ground. Okay, today, not only here, but everywhere, the most common method of bringing the power into not only homes, but buildings is an underground feed. Overhead feed is the old method of bringing power into a house. We don't use overhead feed in new construction anymore. Question for Daniel. Daniel, electrical current is measured in what? Amps. Amps, named after that French fellow, Mr. Ampere. Amperes, amps, that's right, fantastic. And Shamir, the most common voltage in North America is 120 volts, Mohammed. Mohammed, yesterday you missed out when we talked about current. Can somebody let Mohammed know about two different types of current? And what kind of current do we use here? Direct current or alternating current? Fantastic. That being said, we started talking about service panels this morning. Today, the standard amperage coming into an electrical panel today would be what? Most common amperage coming into an electrical panel today is 200 amps. 200 amp service. Fantastic. What is the most common circuit breaker in a house? 15 amps. And what wire gauge would I need for that 15 amp circuit? American wire gauge 14. Can you remind everybody, before we use circuit breakers, what did we use to complete a circuit? Or what did we use to protect that circuit? Fuses, ladies and gentlemen, fuses. Absolutely correct. Why don't you give us 3 or 4 wire gauges and the amperage they carry? American wire gauge 12, how many amps does that carry? 20 amps, very good. Can you give us at least a couple more? American wire gauge 14, well, we know how many amps that carries. You want to remind us? 15 amps. Yes. Okay. Abdali would like to know another wire gauge and the amperage it carries. American wire gauge number 6, how many amps does that carry?
55 amps.
55. And where would I want to use that wire gauge? For what? That's right. We use it for the main ground wire. Fantastic. Excellent. What wire gauge do we use for a stove and how many amps does it carry?
8.
And how many amps does that carry?
40 amps.
40 amps, just like that, 40 amps. Jamal, American wire gauge 14.3. How many conductors in that wire? What colors are they and what do they do? So you're saying in American wire gauge 14.3, we have a red wire, a black wire, and a white wire. What does the white wire do? Neutral, just like Switzerland. The wires that come into the house, the standard voltage and amperage that comes into our home, how many wires come into the house and what are they providing us? Maybe Daniel would like to assist us here. Daniel, how many wires enter the home and what do they do for us?
We have 3.
3 wires.
3 wires.
Okay. And what are those 3 wires?
Well, there's a neutral and 2 with 120 volts.
And 2 with 120 volts. Oh, right. Now we've got the power. All right. Fantastic, ladies and gentlemen. A little question that we brought up yesterday, and I'm hoping to talk more about this later on today when we start talking about connections. Whenever we have wires that are going into an electrical box that are not connected to a switch or a receptacle or a light, what do I need to do with them?
Yeah, because if you are not using, we have to cover it.
We have to protect the wires. And if those wires need to continue from one box to another box, we need to connect them and cover them with a
wire nut.
I just happen to have one in my hands. So I am going to just show us some of our more basic electrical tools that we would use, specifically screwdrivers and different types of pliers. And then we'll even look at some testers, okay? Yesterday, we showed you some fish tapes, which is a tool. Of course, let's not forget, here's another one I have right nearby. Tape measure, we always have to measure things. If I can recommend some tool manufacturers for electrical tools, I would highly recommend Channel Lock, Klein, and Greenlee. Those are excellent manufacturers of electrical tools. So I would recommend Channel Lock, okay? Channel, Channel, Lock, Lock, Klein, K-L-I-E-N. Okay, Green-Lee, G-R-E-E-N-L-E-E. The color of our screwdriver actually is telling us what kind of screwdriver I may need to use. You see, when you're an electrician and you have a pouch with all your screwdrivers in it, simply by looking at the color, you'll know if you're going to be pulling out the screwdriver you need to do the job. So the colors actually mean something. I'm going to show you the most common screwdrivers used by electricians today. The most common screwdriver head that electricians will use, if you take a look at these screwdrivers right here, they all have a square tip on them. You see that? They all have a square head. Square. You see them? They're all square. This is what we call a Robertson screwdriver. Robertson screwdrivers, Canadian invention, ladies and gentlemen. All right. And if also I want to point out, just with the few that I picked up, you can see some of them are longer than others. What does the color actually mean? Well, you can buy the screwdriver with the various colors, or if you buy generic screwdrivers, the handle might all be the same color, but there will be specific markings on it. For example, you can see these two screwdrivers are the same color handle, but this one has a red line on it. This one has a black line on it. I can also get the same screwdriver if I look around, same handle with a green line or a yellow line. See, or even a beige line. The color actually tells us the size of the square tip that we're using. You look at this one here, it's got the largest square tip. It's going to be the black handle. You'll see over here, this one here has got a black stripe on it. I also have a black handled one here that has the largest square. The next screwdriver that is slightly smaller than this one is going to be the red handled one. So if you look at the square on this one, it's just slightly smaller than the square tip on this one. This screwdriver here and this screwdriver here, generic handle, but it's got a red stripe on it. They're identical, same size tip, ladies and gentlemen. Okay? Every screw has a larger or smaller head that needs to fit the screwdriver. So the largest head is the black one. The one that's slightly smaller is red. The one that's slightly smaller than that is the green. There are other ones that I don't have here with me right now because I don't have all of my electrical tools in here with me. I just have some. I've got a wide variety of tool bags, ladies and gentlemen, that have basically a handful of all the tools in every bag. I can grab any bag in my garage and I'll probably have all the tools I'll need to complete a job. So that being said, ladies and gentlemen, after the green screwdriver, we will have a yellow handle, which is going to be slightly smaller than this. We will have a beige handle, which will be slightly smaller than this, all with the square Robertson tip. When it comes to electrical, the most common, of course, there are other screwdrivers we can use. Let me just show you a few more. Of course, this is a flathead. This is a Phillips, another Canadian invention, the star-shaped one. Phillips. Yes, there are a lot of electrical equipment that might have flathead or Phillips as well. But realistically, most here, especially in Canada, most electrical equipment, I'm going to show you two Robertson screwdrivers that will allow you to do easily 75 to 80% of all of your connections. That will be our red Robertson and green Robertson. The red Robertson will be able to make most of your connections in panels, electrical boxes, junction boxes, and so on. The green one will allow you to make a lot of connections with switches, receptacles, and so on. These two here, you can do a lot of electrical work just with these two screwdrivers right here, ladies and gentlemen. Of course, when we take a look at the handle length, the shaft, the longer the shaft, the more torque you're going to get in a screwdriver. So if you have a very long screw that you're putting in by hand, the longer the handle, the easier it's going to be to put that screw in. But sometimes we can't fit a very long screwdriver into the area we're trying to put a screw in. These little skinny ones here, again, I can get them with a variety of heads. This is a flathead. I can get this as a Phillips. I can get this as a Robertson. I can get it as a Torque as well. When we have skinny shafts like this and they're this tiny, we would call this a precision screwdriver, mainly for doing delicate work on little computer boards and so on, control boards. Then we can get something like this, but with a longer shaft on this. I use this a lot for things like thermostats, doorbells, alarm systems, and so on. Longer shaft, longer handle, it gives me more torque. Here's another short screwdriver, just as long as this one here. But these little guys right here with the fat handle on them, we call these stubbies, okay? Of course, now this allows us to grab the handle much easier and get more torque. I've got 3 different stubbies right here. Again, if you take a look, red stripe. Well, this red stripe, Robertson screwdriver, it is the same size as this Robertson screwdriver. Red, red. Same as this one as well. But this one allows me to get in tight spots. Stubbies. Of course, this stubby here is a Robertson. This one here is a flat. And here is a Phillips, just to give us a couple examples of the different screwdriver heads. Okay? And of course, we can even get any one of those screwdrivers with even longer shafts. Sometimes we need, like I said, the longer the shaft, the more torque we will get. It allows us to put screws in a lot easier. For example, if I had a 3-inch screw, it's going to go in much easier with this one than it will with this one. These are both flathead screwdrivers. Keyhole saw. We remember this from the drywall days. We might have to cut a wall open to get to our wires. Or we may need to make holes for ceiling lights or light fixtures. Again, after things have been done, Jamal says, hey, you know what, Nardo, can we add another receptacle here or another switch? Well, I'm going to cut the wall open with one of these. When we're putting panels up, a level comes in handy and make sure we're putting that box nice and level, nice and plumb, nice and square. Channel locks, very common tool that electricians will use. A lot of times an electrician may need to cut conduit or certain types of cable. Hacksaw. Electricians need to hammer things in as well. Hammer. Sometimes we need to have light. This is a flashlight, ladies and gentlemen. There's a flashlight, which the batteries are dying on right now. This comes in very handy. I can hook it up on something. It's also got a magnet here. So if I've got anything, I can secure it with a magnet, or I can open up this clamp over here. I can secure it onto something to hold it up, or maybe I have nowhere to hang it. I might just put it around my neck. We know sometimes we're working with metal studs. We may need snips as well. Earlier on, we talked about in our service panels, when we're making connections, especially with the larger wires, the connections we will be putting under, remember those lugs we talked about? Well, you might need an assortment of what we call Over here, we call these Allen keys. In the States, they like to call them Allen wrenches. They come in a wide variety of sizes. You can see these packages look very similar. Well, the one with the red handle, this is all imperial measurements. The one with the blue handle, these are all metric. And then, of course, they come in a variety of sizes and styles as well. Ratchets for those same lag bolts sometimes require a ratchet. Another common tool electricians might use for certain heavy-duty wire, we might want to use a hook knife, comes in handy, especially with the larger cables. As you can see, this extends up and down. It's a magnet, ladies and gentlemen. This comes in handy. Sometimes you drop something in a wall. Well, you know what? I can pull it out of the wall easily. This is what we call a linesman plier. Okay? Do yourself a favor when it comes to buying electrical tools. Don't be buying your electrical tools at the dollar store. All right? Now, if you could see, like I mentioned before, I like channel lock tools. Channel lock tools, all their tools have this light blue color to them. That is their trademark color. This is a linesman plier. I wouldn't get a plier any shorter than what I'm showing you right here. Okay, you can actually get linesman pliers that are a little longer than this, whatever you're comfortable with. I like this size. Okay, Klein, like I said, they make great tools as well. I like the way channel lock fits in my hand. Now, when you buy a linesman plier, you don't have to have one this good. All right, this one has a couple extra features on it that I use for a lot of other connections I will make. You don't have to have all those features. For example, this one here, this particular linesman plier, if you were to go out and buy it, it will cost you approximately $90. Okay? It'll look, you can find other ones that'll look very similar to this, especially if it's a channel lock, but it might not have this feature here, or even this feature here, or the knurling here. This thing here, it's got knurling here, which allows me to make certain connections. This C-shaped thing here is ideal for certain connectors that you need to put on wires. That allows you to crimp it down. Here, you'll notice we have a little tiny hole right in the middle. That little hole is meant for our most common wire gauge when we are stripping the sheathing off of the conductor. Can somebody remind us what that most common wire gauge is once again? American
14.
wire gauge 14, that's right. 14. So this allows us to clamp down on the wire without nicking or damaging the conductor. Because if you nick or cut into that conductor, even just the slightest amount, when you go to twist your wires together, that conductor can easily snap. So this is to ensure we get a clean stripping when we don't want to damage the conductor. Also, this plier is different. Plumbers also use pliers, but a plumber's plier, if you look at this jaw and this jaw, they will actually close in on each other nice and tight. If you notice as I run my finger in behind, you can see my fingertip going up and down. That gap, again, is purposely left there for, again, our most common wire gauge. When I clamp down on it, it allows me, for example, when I need to make a connection, I can grab, let me just fix some of these wires here just to give a little bit of a demonstration. It allows me to put more than one conductor in line with each other. Okay? I can simply line up my wires in the jaws, nice and easy, next to each other, and twist them together. Ladies and gentlemen, another little tip that I want to give all of you. When you're going to make a connection with your wires, for example, when I'm going to make a connection with a wire nut, never do this. See, some people, they're afraid. and they don't want to touch anything. They put the wires close together, and then they put the wire nut on it, and they're relying on the wire nut to keep those together. Well, sometimes you might be lucky and it'll hold them together. A lot of times you'll see, there you go, look how easy that wire came out. It's not holding anything. When we make connections with wires, ladies and gentlemen, before you put your wire nut on, put your wires together, okay? Put them in your linesman plier, ladies and gents, and then twist them together in a clockwise orientation. Always twist your wires together in a clockwise orientation. Now that these wires are twisted together, they already will not come apart. So before you make connections, always twist your wires together in a clockwise orientation, because when you put the wire nut on, you're also turning it in a clockwise orientation. Now watch what happens as I tighten this wire nut. You're going to see the more I tighten it, these wires are going to start to twist themselves together even more. Now I know I have a good, strong connection. And that is how we connect our wires together. Don't just put the wire nut on top and hope it's going to work. Another no-no, ladies and gentlemen. A lot of people do this because they're afraid. They do what I showed you before, and then they will put tape on top of it. Oh, that'll keep it together. No, don't do that, because you're actually creating a safety hazard. Because now you think this is going to protect you. If it comes apart, you can accidentally get a bad shot. So avoid putting tape over joints. You just want to make sure you make your connection proper. So a linesman plier, very important tool when it comes to electrical. You're not an electrician if you don't have a linesman plier. Here's another tip. Depending on how much strength you have in your hand, the longer the handles, always when you use a plier, hold it as far back as possible. It's going to give you more leverage. So if you have to cut several cables or wires simultaneously, the more leverage you have, the easier it will be to cut your wires. Rule number one, when we're working with electrical tools, even if the power is off, remember, always assume, even if you know the power is off, work as if the power is on. So you always want to think that the power is on so we work safe. This is another very important tool when it comes to doing electrical. Also a plier, but this one here you'll notice is cut on an angle like this. This is called a side cutter. Very good tool, very handy when we're working with metal clad wiring or armored cable. It also allows me to get in a box nice and close to the wire and cut it. So another very important factor when you're working with electrical tools, make sure that your tools are properly insulated. This has got a long nose on it. We call this a needle nose. Also allows me to cut wires if I had to. This is some stranded wire. This tool here is what we call a wire stripper. If we take a look, you'll see there is a series of holes. See those holes? And you may even be able to make out those numbers. 16, 18, 20, 22, 24, 26. This wire stripper allows me to strip wire gauges very easily without damaging my conductor. Okay? This particular one allows me to do wire gauge number 16 to 26 very easily. All I need to do, of course, I can strip this like so. And if I just strip it like this, ladies and gentlemen, I'm going to show you. Look at, I'm stripping the wire, but look at how many of the conductors got damaged. Look at what's left here. I don't have enough strands here. That connection will not be a good connection because it's not giving me the proper wire gauge. What's going to happen is that will overload. It's going to get hot too fast, and I'm going to trip the circuit. Now, if I was using, see, I used the wrong jaw on that on purpose to show you what would happen. But if I use the proper wire gauge stripper on that, I just bite into it, and now when I strip it, you can see that all of those little fine strands are left perfectly intact. I twist them together. I've got the proper wire gauge there with the single strand wire. You see what just happened there? This is what we call a spade bit. A spade bit, ladies and gentlemen. They come in a variety of sizes. Depending on the size of the hole I need to drill through my studs when I'm running wires through them. Again, when we run wires through our studs, always put your hole as centered as possible. So if someone should happen to put a screw through here and a screw through here, we know what the common length of our drywall screw is. It's not going to go into our wire. Also, when you're making holes for your wires, make sure the hole, depending on the number of wires that you're going to run through that hole, make sure the hole is at least 1/4 inch in diameter, larger than the wire that's going to be going through it. Now, as an electrician, the smart thing to do is always, anticipating you might want to run more than one wire in that same direction, you make your hole slightly larger so you can run more than one cable through the same hole. Now, we can get these bits. They come in a variety of lengths and diameters. For example, we showed you the other day when we were talking about augers. Here's another bit. This is a 1-inch bit, longer handle. I would use this to drill holes through joists to run my stove cable, for example. Again, you can see the variety, different sizes of our bits. This is just a short bit, but if I had a longer bit, sometimes when we're drilling holes through our studs, we know that we want to have 16 inches on center between our studs, but we also know that sometimes our studs might be too close together. For example, I might have one stud here and another stud right here. As you can see, even though I'm using a short screwdriver, it's very difficult for me to get the drill in between to drill through that stud. Am I making sense? Here's another good little tool that you might want to invest in. Let me show you this one. When I'm in tight spots, ladies and gents, I will put this on my drill now. This allows me to get in those tight spots and drill just like that. It is now 12:30. We will see you at 10 after 1. Bon appetit, everyone.